of this form. Remember, you cannot do that for any form. In cases where continuous differentiation of u gives you 0 and the dv when you integrate will keep the same identity. What does that mean? You see, e to the power of 2x, when you integrate you get e to the power of 2x over 2. And when you integrate that, you get e to the power of 2x over 4. And if you integrate that, you get e to the power of 2x over 8. You can see the same form keep coming back every time. And that is the form of dv that will suit for the table method. So, there are two conditions to be satisfied if you want to use table method. What are the conditions? One is the quantity you choose as u. When you differentiate it continuously, you must get 0. In other words, if you have x to the power of 4, when you differentiate x to the power of 4 continuously, you get 0. The derivative of x to the power of 4 is 4x cubed. The derivative of 4x cubed is 12x squared. The derivative of 12x squared is 24x. The derivative of 24x is 24. And the derivative of 24 is 0. You can see ultimately you reach 0. And the dv must be such that when you integrate it continuously, the same form must come back. Like, if dv is sine x, you can see integral of sine x is negative cos x. But integral of negative cos x is negative sine x. You can see you come back with the same form. So if you keep integrating, you keep getting back the same form. So once again, in cases where continuous differentiation of u gives 0 and the continuous integration of dv keep the same form or the same identity, then we can use a quicker method. Again, a warning for you, this is only possible for this particular case where u and dv satisfies this particular form. Now, for example, quantities like x to the power of n, e to the power of mx. This will satisfy that because x to the power of n, when you differentiate continuously, you will reach 0. And e to the power of mx, when you integrate continuously, you will keep the same basic form. Integral of e to the power of mx is e to the power of mx over m. And you integrate that again, you get e to the power of mx over m squared. Is that right? If you integrate it again, you get e to the power of mx over m cubed. You can see you'll keep getting back the same form. Or x to the power of n cos mx or sine mx. They're both the same. So these are the forms that will suit the table method. You cannot really use any other method. Now, how do you construct a table? Follow this method. Construct a table with u in the first column and dv in the second column. So you got u in the first column and dv in the second column. Let's take this example. Consider the example integral x squared e to the power of 2x dx. This is the one we just did. And we obtained the result for that. Alright, so in here we write u below u and write dv below dv. And what is our next row? In our next row we find the derivative, differentiate u continuously and write the results in rows below until you produce 0. So differentiate u continuously and write them rows below. So The derivative of x squared is 2x. The derivative of 2x is 2. And the derivative of 2 is 0. And you have reached 0. That's what this means. Differentiate u continuously and write the results in rows below until you reach 0. And what is the next thing? Go to the next column. Integrate dv continuously until you reach the last row. The last row is the row that contains 0. You don't go beyond that. Well, integrate dv continuously and write the results in rows below. Tell me, what is integral of e to the power of 2x? Integral of e to the power of 2x is e to the power of 2x divided by 2. Let's write that here. E to the power of 2x divided by 2. What do you get if you integrate this? Integrate e to the power of 2x divided by 2 will be e to the power of 2x divided by 4, because one more 2 will come down. So that will be the integral of integrate e to the power of 2x divided by 2 is e to the power of 2x divided by 4. And what do you get if you integrate this? It will be e to the power of 2x divided by 8. That's right. Okay, now we have completed that. What is the next thing? Assign alternatively positive and negative signs to u and du. So, if the u is positive, then the next du will be negative, the next will be positive, and the next will be negative. Assign positive and negative signs to u and du values. And that's what I have done here. Then, multiply values below u with the values below dv. That is, if you choose this value of u, multiply this u with diagonally opposite dv. Look at that. This way, multiply this way. Multiply this u with that v. This is of course v. So this is u times v. Alright, so multiply this and write down that is your first term. So what is our first term in the integration? It will be x squared e to the power of 2x divided by 2. That is the first term. X squared e to the power of 2x divided by 2. What is the next term? Multiply the next du term with that dv. Let's go like that. But that is minus 2x e to the power of 2x divided by 4. Minus 2x e to the power of 2x divided by 4. And next one is 2 multiplied by e to the power of 2x divided by 8. So that will be plus 2 e to the power of 2x divided by 8. And we have done, because if you now multiply with 0, that will be 0. So that is the end, and then you have a C. And this, you know, we simplified and got this e to the power of 2x divided by 4 times 2x squared minus 2x plus 1 plus c. This is the one we did earlier. Alright, so practice this table method. It's a very simple method, but it can be applied only for integration forms of this type. Okay, just practice this with another example. Use table method to evaluate the integral x cubed cos 2x dx. Alright, what is your u? U is x cubed, and your dv is cos 2x dx. So u equal to x cubed, dv equal to cos 2x dx. Let's make our table. Now write your u and write your dv. What is the method now? differentiate u continuously and write below in rows until you reach 0. The derivative of x cubed is 3x squared. Is that right? So that is derivative of x cubed is 3x squared. What is the derivative of 3x squared? Will be 6x. And what is the derivative of 6x? Is 6. And what is the derivative of 6? That is 0. So we differentiate x cubed continuously with respect to x until you reach 0. Now on the right side, what do? We integrate dv. This is our dv. Integrate dv continuously until you reach the last row. Alright, what is integral cos of 2x dx? Now there must be a dx there, because your dv is cos 2x dx, so don't ignore that. Integrate cos 2x dx will give you, alright, talk to yourself. Integral cos 2x dx is sine 2x divided by 2. Remember, integrating cos will give you positive sine. Integrating sine will give you negative cos. So integral cos 2x dx is sine 2x divided by 2. Alright, integrate that again. What do you get if you integrate sine 2x divided by 2? There's of course a dx there, don't ignore that. Integral sine 2x over 2 dx will give you negative, see, integrating sine 2x will give you negative cos 2x over 2. And that 2 will combine with this 2 gives you a 4. So that will be negative cos 2x over 4. And what do you get if you integrate this? Integral of negative cos 2x over 4 dx will be negative sine 2x divided by 8. There you go. Alright. Now if you integrate that, what will be that? Write that on your own. What is integral negative sine 2x over 8 dx? What does that give you? Integral sine 2x dx is negative cos 2x over 2. So that negative and this negative will make it positive. So that will be positive cos 2x over 16. That's right. So we integrated cos 2x continuously. And how do you pick our answer? First of all, assign the sign. Start with positive. Is that right? So assign alternating signs for u and dvu. That will be positive. This will be negative. That will be positive. That will be negative. And positive. But we don't need this because we will not be multiplying with 0. So what is our first term? Pick your first term like this, diagonally. It will be positive x cubed times sine x over 2. There you go. X cubed times sine x over 2 is the first term. What is the second term? Minus, you see that there's a minus there and a minus here. When you multiply the two negatives, it will become positive. So that will be plus 3x squared cos 2x over 4. You see how the plus came? Because of the two negatives. That will be plus 3x squared times cos 2x over 4. And the next one, this is positive, that is negative, so that will be plus 6x times minus sine 2x over 8 will be minus 6x sine 2x over 8. Is that right? And the final one will be, that's minus, this is plus, so the result will be minus. That would be 6 cos 2x over 16. That's right. And you can simplify some of these. And that will be x cubed sine 2x over 2 plus 3x squared cos 2x over 4 minus 6 and 8. You can divide by 2. That will be 3x sine 2x over 4 minus 3 cos 2x over 8. Again, you can divide by 2. Integration by parts.